Hello, my name is Mark Gleason. I'm a plant pathologist at Iowa State University. I'm leading a project that's aimed at making pest and disease control on apples more efficient. Today I want to give you some background on a summertime apple disease called Sooty, Blotch, and Flyspeck. I'll describe a bit about it and explain how it fits into our current IPM project. Sooty, Blotch, and Flyspeck, which we abbreviate as SBFS, is kind of the Rodney Dangerfield of apple diseases. It gets no respect, but it can cause some heavy losses of money if the control fails. If you've been growing apples for a while in the Midwest or the East or the South, Sooty, Blotch, and Flyspeck will likely be familiar to you. But how well do you really know it? Sooty, Blotch, and Flyspeck fungi form colonies on the apple surface in a range of patterns from smudges to clusters of dots. This is where the losses come in, since nobody wants to buy smudgy, spotty apples. There's no genetic resistance in apples to Sooty, Blotch, and Flyspeck fungi, but yellow-skinned apples are the most vulnerable to losses, since the dark colonies of Sooty, Blotch really stand out against the yellow background. Ironically, Sooty, Blotch, and Flyspeck fungi are not very damaging to the fruit, since they never get below the peel into the live tissue. They live their lives only on the peel. But they can still do plenty of damage to your bottom line. Sooty, Blotch, and Flyspeck is a threat almost everywhere in the eastern half of the U.S., especially during rainy growing seasons. The colonies of these fungi usually show up on apples in mid to late season. When apples are pulled out of storage, some of the colonies can be washed off in a dip tank, followed by brushing on a grading line. But the removal may not be good enough for market standards, and many Midwest growers don't use dip tanks. The result is that most growers in our region use fungicides to prevent Sooty, Blotch, and Flyspeck. These sprays are applied every 7 to 14 days during the fruit development period. This can amount to anywhere from 4 to 10 fungicide sprays between first cover and harvest, depending on the apple variety and the local climate. The good news is that Sooty, Blotch, and Flyspeck outbreaks are fairly easy to prevent with fungicides. But if spray timing gets delayed, or pruning gets behind, or the growing season is especially wet, Sooty, Blotch, and Flyspeck can show up on the fruit. In much of the Midwest, Sooty, Blotch, and Flyspeck is the major disease threat to apples in the summer. That means that most fungicide sprays are aimed at it. Can growers get the same high level of Sooty, Blotch, and Flyspeck control with less fungicide and lower cost? That's where our project comes in. There are basically two ways to economize on fungicide sprays for Sooty, Blotch, and Flyspeck. Either cut the number of sprays or cut the amount of fungicide per spray. Our project is working in both of these directions. Now I'd like to talk about disease warning systems. First, how can the number of summertime fungicide sprays be reduced? This is where disease warning systems come in. Fungi really like moisture. Sooty, Blotch, and Flyspeck fungi are generally active when the environment is moist. The more hours of dampness in the summer, the happier and more damaging these fungi are. How can we turn this moisture-loving behavior of the fungi to our advantage? Sooty, Blotch, and Flyspeck is more of a threat under wet conditions, so fungicide sprays are more necessary then. But when conditions go dry, Sooty, Blotch, and Flyspeck fungi stop. In Iowa in 2020, for example, we had 0 Sooty, Blotch, and Flyspeck even on unsprayed apples because it was simply too dry during the period that the fruit was developing. So why spray when the risk of sooty, blotch, and flyspeck is minimal or non-existent? This is why we've developed a sooty, blotch, and flyspeck disease warning system for the Midwest. From years of experiments, we figured out how to avoid some summertime fungicide sprays on average. Here's how the warning system works. After the first cover fungicide spray goes on, we start counting up hours of relative humidity that are above 90%. This is very wet conditions now. We add up the hours of relative humidity above 90% until they reach a total of 385 hours since the first cover spray. Then it's time to get back to a normal fungicide spray schedule every 7 to 14 days until close to harvest. In Iowa, we've saved an average of about 2.5 fungicide sprays per year by using the sooty, blotch, and flyspeck warning system. In wet years, we might save 1 spray or even no sprays, but in dry years, we can save 4 sprays compared to a regular spray schedule and still get excellent sooty, blotch, and flyspeck control. It takes a bit of monitoring to keep track of relative humidity hours above 90%, but these days it's quite simple and inexpensive. A relative humidity sensor in your orchard, which costs a few $100s, could quickly pay for itself in spray savings. Now let's look at the other option for saving pesticide that we are testing in our project. This is the intelligent sprayer. Using a new air blast sprayer technology is potentially another way to cut back on pesticide spraying. This new technology is called an intelligent sprayer. It's not really intelligent, but it sees the orchard in a way that a standard air blast sprayer does not. The intelligent sprayer technology was recently developed by the USDA Spray Laboratory in Worcester, Ohio. It looks to be the most important advance since air blast sprayers went on the market about 60 years ago. How does the intelligent sprayer work? It uses reflections from laser beams to see the foliage and fruit of the nearby trees. The sprayer's computer translates the reflections into a 3-dimensional image of each tree. Then the computer tells the nozzles when to spray and for how long. The result is a big increase in efficiency because the intelligent sprayer results in much less off-target drift. More of the spray actually hits its target, 30 to 60% more than for a standard air blast sprayer. The result is that the intelligent sprayer uses much less spray per acre every time you spray. You don't need to refill the spray tank as often, and less fungicide and insecticide is wasted. Field trials in several states have shown excellent disease and pest control, even with the reduced amount of pesticides sprayed. Looking back at these new technologies, they can save sprays in different ways. Warning systems, like the one I described for sooty, blotch, and flyspeck, can cut back on the number of spray trips. On the other hand, the intelligent sprayer cuts down on the amount of spray volume you apply per acre every time you spray. Both of these technologies have the potential to improve IPM efficiency. But what happens when we combine them? How can we maximize efficiency? That's what our USDA CPPM project is about.